Cool. Hello. What a nice crowd we are having today. Right. Anyone, I guess, interested in multiplayer games? Hands up. Nice. Excellent. All right. Anyone who tried making a multiplayer game? Uh-huh. And how was it? Who enjoyed it? Okay, I see some. Cool. I think there's one person who had fun with it. Anyone run into troubles? Wow. Yeah, that's almost everyone. All right. Adam, welcome to my talk. It's an increasingly frustrating tale of, okay, but... So let's get into it. And I would like to start with a confession. Is that I have this, let's say, obsession since 2017. And it's also about making multiplayer games. And it's kind of difficult. Hope it's kind of visible there, but yeah, those blue guys should not be teleporting around. That's not what I wanted. And those green bars you can see, absolutely not where they should be at all. But, you know, overall, I had this idea for this cool game. It was gonna be amazing. You could play with your friends. It could do couch co-op. It could do online. It could do both at the same time. You would have customization. You could have custom loadouts, whatever. And that's where I got with it. So not much of a success so far. But why is it difficult? All right, before we get into it, who am I? A few words about me. My name is Tamás. I have started with GameMaker in 2006. I spent a bunch of years in Unity. And actually the first time I tried Godot, it was, I think at 2.1 or something like that. I did not like it at all. Anyone try that version? Feelings, was it good? Okay, it was mixed, that's fine. That's a long while ago, so I think we can agree that Godot 4 was miles better. That's where I also started with it. And this was actually months before the Unity runtime fee fiasco. I felt so vindicated, it was amazing. I mean, not for the Unity people, my condolences, but for Godot people it was great. Okay, in my professional life, I'm a backend engineer for I think the last 8-ish or something like that years. And as of more recently, I've been working at a runtime called Elide. For my web dev people out there, if there's any, think of it as a, I see some of you, cool. Think of it as a Java compiler, a runtime and the toolchain all in one, except it's much faster and you can mix and match your languages like Java, JavaScript, Python, TypeScript, etc. Anyway, as a conclusion, I've been messing with this for a long while. So, what are we going to touch on today? First, what is multiplayer actually? How do you solve it? How do you solve it using Netfox, which I'll explain what that thing is. And what if you just really don't care about this at all? And lastly, if you have some time, we'll move a bit beyond netcode. All right, what is multiplayer? Basically, you want to have everyone see the same thing. Simple, right? It's just send over the data, display it, you're good. Well, okay, but what about cheaters? I mean, if each client sends their position, clients can start lying. Well, okay, I don't care, but you know, what about interactions like when two clients are doing the same thing at the same time? Let's say you have a shared pool of minerals, gold, wood, whatever, and two players want to spend the remaining gold at the same time. Who actually spent it? Okay, and for my next magic trick, I'll challenge my hand-eye coordination by speaking and running a quick demo at the same time. Excellent. Okay, so this is a tiny multiplayer application. And on the left, there's the server. I can walk around. Excellent. And on the right, there's the client. And this is client authoritative, meaning that everyone broadcasts their position. What the client says about itself is the truth. And this is working great so far. But the thing is, we are playing with perfect network conditions. Let's try decent. So now I have something like 100 plus milliseconds of latency. Feels fine. Let's go for horrible. That's gonna be a literal half a second for data to make a round trip. Looks good. Maybe you can see on the left side that there's some lag. And there's this tantalizing button over here. So let's do some cheating. Okay, that was trivial, you could say. So in conclusion, this is pretty responsive, works well with bad latency, but it's the easiest to cheat. Okay. So let's try server authority, in which case the server owns the game state. The server is the source of truth. What the server says is what is. And all the players can do is submit their inputs. So think about it in terms of no more saying, I am at this position or at there, or my health is this much, etc. Now your clients can say stuff like, I want to move to the left, I want to jump, I want to move forward, stuff like that. So in this case, what happens, whoops, as the client sends over their inputs, the server processes those inputs and responds with the results. So if you say you want to move to the right, the server will say, okay, you are now this position to the right. And this is cool because no more confusion and interactions. You can't have this kind of conflicts. There's only the server and its truth. And that's okay, but what about latency? Because data takes time to arrive. And often that's fine, maybe, but they kind of dislike it in action games, as far as I heard. So let's see this as well. Oops, wrong button. Excellent time to exercise the wrong buttons. Okay, server on the left, client on the right. Perfect network conditions, feels absolutely fine. Unfortunately, most of the people are not playing with perfect network conditions, so let's just go ahead with horrible. And this is bad. This feels bad. Let's just, I tap it once. That's kind of tough to play with, actually. Not sure if you had a similar experience. All right, fine. Let's say we've got good conditions, and it's time to cheat. What? Why? No, I wanted to fly. This is annoying. Okay, try again. That's ridiculous. It's not working. Anyway. Okay, back to the talk. So, why could I not cheat? Because everything happens on the server, and the cheat was the client telling everyone that, look at me, I'm flying. But since the client has no authority in this, it did not fly. And as you saw with the latency, we had to wait for the server to reply to every single one of our actions. Hence, it felt pretty bad with latency. Oh, what's this? All right, we've got a misconception on our hands. And it says, I've tested locally on local area network and it works. Anyone ran into this? I did. Okay, there's a few people. Cool. Happy to have shared the same suffering. Thank you. So, let's talk about this. If you are running, let's say locally, like you are running the game in 2 instances on your PC, or on a local area network, like you have the game running on your PC and on your laptop, let's say, and they're both on the same network, you basically do not have any latency. And that also means that updates arrive instantly, so almost whatever you do, it will just work. And if that's your target, if you want people to play your game strictly on the same network, great, problem solved. You can leave this talk, you have all the tools you need. But if that's not your target, which is kind of happens often, then latency will absolutely break your game. So make sure to test your game with latency, either with real one, though that's a bit more tedious, or you can use simulated latency. Okay, back to the talk. How do we solve this issue, this whole multiplayer of a mess? Well, you can try client-side prediction. We'll have the same setup as previously. Server has all the truth, and clients only send their inputs. The big difference is that all the clients will apply their inputs locally. So instead of waiting for the server to reply, you just move your guy to the right if you're pressing the right, because you can reasonably expect that the server will agree. So that's the prediction part. And there's also a server reconciliation component to the whole thing, which basically means that you have sent your inputs to the server, you have predicted what will happen, and now the server responds with what actually happens. And if you wrote your code correctly, almost all the time these two will match. The server will confirm what you've predicted, but if there's any misprediction, clients will just correct. They'll just move the player to the right place, for example. You'll see. And that's just excellent. We've solved latency, kind of, in the sense that all of your local actions will feel instant since you are predicting the result. Almost no cheating as well, in the sense that you can just lie about your state to the server or anyone, since, again, same benefit as with the server authority. You do not have that kind of say into the things. And that's okay, but how do I get started with this? And do not worry, I'll just do a quick rundown of this whole thing, but I will clear it up a bit later. Okay, so first off, you will need a tick loop. You want to make sure that the game is updated at the approximately same rate on every client. You also need to synchronize your clocks so everyone has a shared notion of what's the current time, when are things happening. You also need to track a history. You need to take regular snapshots of the game state so you can go back in time. You will see why. You need to take a similar history of your inputs, who wanted to do what and when. And you also don't want to have too many of these snapshots. You want to have an upper limit, otherwise you'll just run out of memory. And we do not like that. You need to synchronize this history as well. So client submit the input, server broadcasts the state. It's also nice to timestamp these, since data takes time to arrive. So you want to know when these snapshots were sent. And now with all this data that have arrived, you want to re-simulate the game in the sense that, for example, the server does not know all the inputs on time, and some client says, "Hey, I wanted to fire this gun 200 milliseconds ago." Okay, then now the server has to go back 200 milliseconds in time, fire that gun, and re-simulate the whole game from there. And on clients, you also need to discern what is predicted, I mean, what is your guess, and what did actually happen. And that's the gist of it, but okay, what about bandwidth? All right, you can do data compression, as in you only send what has changed. You can do some custom serialization, and it's fine, but what about tick rates? As in, what if the game updates at 30 frames per second, but you want to render at 120? Okay, you can do interpolations. I hope we are done with these questions. No, we are not. Okay, what about jitters? You can do display offset, which means that you are showing a state from the past, like 100 milliseconds ago, which means that you have more time for data to arrive and for the game state to correct itself. Okay, we have visibility as well. Well, I hope this will end soon. There's just too many stuff to worry about. Okay, you can do interest management as well. Let's say you have an ability where you go invisible. And if the server keeps sending your position to other players, you are not actually invisible because they still know where you are. It's easy to cheat. So you need interest management as well. Okay, what about physics? Yeah, okay, have fun. This is something that Godot kind of does not want you to do, because if you want to re-simulate your game, you need to simulate multiple steps in the same frame. I hope that makes sense. And the issue is that Godot updates its physics world only once per physics process. So the physics world will be behind your game state for a bit, and that just screws up everything. So yeah, have fun with your physics projects. I wish you the best. Okay, but what about a game? I still don't have a game. I want to make a game. Okay, so if you just want to make a game, the ideal, in my opinion, feel free to disagree with me on this, is that you just put your game logic in some callback. Let's say you copy it from physics process to something else, whatever, just have it in a place. You then configure what you want to synchronize, and then the rest just happens. It's not for you to worry about. I think this would be a pretty good setup. And good news, there's this thing called Netfox. And I always forget to explain what it is in this slide, so not this time. Netfox is basically a set of add-ons built exactly for this. The whole point of it is to make making multiplayer games easier, or at least something that you do not lose sleep over. Okay, so let's see this in action once again. Cool, I hit the right button. I was concentrating so much. Amazing. Okay, so we have our game once again. I can walk around. Everything's fine. And mind you, once again, this is running with server authority, so whatever the server says is the truth. So let's ruin this experience with latency once again. Okay, what's this? This does not suck. I press the button and the little guy moves. So far, so good. Okay, what if I try to cheat? Let's say I want to go through this wall. And it's kind of jittering, but the important thing is what you see on the left is I start walking into the wall and I just can't go past it. This is what everyone else besides you sees. And why this happens is because your client is predicting that it can go through the wall, but the server disagrees. So that's why it kind of gets reset from time to time, depending on your latency. And that's also why I'm falling down here. So basically, we have managed to combine the responsivity of client authority with the, let's say, safety of being server authoritative. Okay, I got the window right. Amazing. All right, so about Netfox and going through all those frustrating questions from before. Bandwidth, yes, we can do data compression. It also does binary serialization. For context, Godot has a built-in format that is rather generic, and it is great at that. But that also means that for every property you want to synchronize, you get a few bytes of overhead, which if you send it 60 times a second for, let's say, 20 properties, that's a whole lot of overhead suddenly. So there's a custom solution built in that lets you skip this overhead. Okay, it can also do tick rates. It also does interpolation. And some of you might have thought of physics interpolation that Godot has. 2 notes on that. Back when I built Netfox, that was in Godot 4.1, at which time we did not have interpolation yet. And also, Netfox can interpolate whatever you throw at it, not necessarily just transforms. Okay, what about jitters? Yes, we have display offset. We also have input delay, which means that if you press a button now, it will actually happen in the future. So by the time the action gets to the server, it's just on time. Okay, what about visibility? Yes, we have that. Interest management, very, very similar to what multiplayer synchronizer offers. Okay, but physics, good news. We can do physics in rollback. Through sheer will, dedication, and contributors, it can be done. But kind of underrated, what about time synchronization? I have spent so much time reading the NTP version 4 RFC document, and I have implemented something similar. It's a tiny bit simpler. For context, NTP v4 is the same protocol that synchronizes the clock on your PCs, your mobile phones, your smartwatches, basically almost anything. And Netfox also does time stretching. So if your clock is ahead of the server, the game will run just the tiniest bit slower. You won't notice it, but you'll converge to the right time. And if your clock is behind, the game will run just the tiniest bit faster. Oh, again, exciting. All right, clock synchronization is easy. I feel like this is niche, but anyone feeling like this? Cool, thank you for your support. Okay, yeah, if you wrote one, then yeah, okay. Yeah, I concede. All right, so let's think a bit about it. How would anyone approach it, kind of? Why not just send a timestamp on join? So you connect to the server, it tells you what the time is. Okay, but we have latency, so by the time you get the timestamp, it will be already out of date. All right, then just measure the latency and add that to the timestamp. Okay, but clocks will drift. And this is pretty wild because I assume that clocks are kind of fine in most of the devices. They can keep track of time. But I had this game where you had a day-night cycle. So during the day, you built your base and such. And during the night, some monsters were spawning. And this was on the same screen, 2 instances side by side. On the server on the left, there was night and monsters were spawning. And on the right, it was shining daylight, which was pretty extreme. And this was just, I think, 50 minutes of gameplay of clock drift. So clocks will drift. Okay, then why not just measure continuously? Okay, but clock jumps are also not so good. Let's say you find out that your clock is ahead by 100 milliseconds, so now you adjust. And now your game will freak out because the data time is a negative 100 milliseconds. Good luck simulating that. So overall, if you have any pre-made implementations available, I think there's 2 in this room, at least. Try that. Or if you want to draw your own, which is also fine, it's an excellent detour, then make sure to take your time. I think for me this was 2 months on and off development, including research. I did even like a whole hour and a half talk about it. So yeah, it's a good project. Anyway, oh no, okay. I had this live coding slide in here. So for my next magic trick, I will convert a simple demo thing to Netfox. Is this readable? Okay, cool, thank you. I think some of those letters are taller than myself. It's amazing. Okay. So down here, there's the live demo folder, and I have a pair node, nothing special. And on the left, we have two multiplayer synchronizers. Mind you, this is based on the server authoritative thing. Anyway, we don't need the synchronizers at all. Netfox has this thing called a rollback synchronizer, and we need to explain to Netfox what are the things we want to synchronize. And one of them is the game state, which will be handled by the server. So I want to synchronize the position, and why the heck not, let's do rotation as well, just for the fun of it. I won't be using that property. And let's do velocity, because I need that for my game simulation. And there's also the input properties. This is basically the data that expresses the player's intent. So on the left here, I have an input node, which I'll show in detail soon. But I want to synchronize its movement property. Okay, I managed to type. Excellent. All right, let's take a look at this input script. First off, there's a class called basenet input that's provided by Netfox. It's kind of a utility. I do not need to export any properties. I can just use them. And instead of physics process, there's this thing called gather, which will gather my input. Excellent. As you can see, there's also this authority check. I no longer need it. It still happens, it's just done by the base class. Oh, and if you're wondering about this window focus check, I'm just doing this in case you're playing with gamepad, so only the focused window picks up your gamepad inputs. Okay, this is the input. Let's move on to the player script. And as you can see, kind of a standard player controller. First off, I have this input synchronizer thing. Do not need that anymore. And am I forgetting something? We will find out. The important part is instead of physics process, you get this callback called rollback tick, where you get the data time, also the current tick that is being simulated, and also a boolean called is fresh, because if you are rewinding the time all the time, then it can occur that you're re-simulating the same tick again and again because new info comes up and then the game world changes, so you need to simulate it again. Is fresh is true if this is your first time running this tick. Okay, once again, authority check, I do not need this. And in this case, the authority check should not happen. Both the server and the client are running the same game logic, so the server can decide the truth and the client can predict what's going to happen. And one more kind of administrative thing. We have this move and slide call, which assumes the data time of the physics loop, which is not the same as the one Netfox uses. Let's say because the physics is running at 60 Hertz and the netcode is running at 30. And I kind of forgot where the multiplication is. Excellent, found it. Miracles today. All right, so this physics factor helps you compensate for it. I'd say if I might remembering the wrong way around, but if physics is running twice as fast as Netfox, then this will multiply it by 2. Okay, and ladies and gentlemen, we did it. I think we have a quick little Netfox demo. Let's see if it works as it should. Okay, server is doing fine. This is also doing fine. Let's ruin our internet connection. Also doing fine. And let's try some cheats. Okay, as you can see, pretty much similar to our previous demo, except this one we built ourselves right here on the spot. Okay. Let's get back to the slides. Okay, so Netfox is cool and all, but any limitations maybe? Yes, I have to be honest, there are a few. So Netfox does this thing called rollback, or as I previously mentioned, client-side prediction with server reconciliation, which is an amazing mouthful. And that means that rollback logic can get kind of complex because anything that happens in your game may also unhappen anytime in your game. You fired a gun. Actually, no, you didn't. You didn't have the ammo, so now you need to clean up after that. You moved to the right. No, actually, you didn't. You are mistaken. These kind of things can happen, and that can get difficult. So I would say this kind of rollback approach is best suited for 4 to 16 players. That asterisk means that I do not have any solid data in this actually. This is kind of a vibe check from my side. Feel free to experiment. But the reason is that since we need to resimulate the game, compute use scales with latency, because the bigger the latency, the older the data you get, the more frames you need to rerun. But not to worry, there's plans to improve on these. First off, rollback is complex. So one of the things that's specific to Netfox is that it has this thing called conditional resimulation. Basically, Netfox checks if you actually need to resimulate something or not, instead of just blindly rerunning everything. Turns out this is difficult because I have seen a bunch of people who wrote their code and the code is not running. Why is it not running? It's right there in the editor. Yeah, because of conditional resimulation, it just did not happen. So now you need to keep that in mind, which is complex. You need to work around it. It's kind of a mess. So this will be an opt-in feature. Actually, I'm working on the PR these days, so it hopefully would come soon. Yeah, and the goal with this is to have things just work TM. I also want to do a docs overhaul. There are documentation for this, some guides, some tutorials, etc., which I think contributed a lot to where Netfox is today. But I want to give a lot more theoretical overview and more kind of in-depth stuff. So that's something on the horizon. And again, rollback has its limits. Since you need to resimulate stuff, you probably don't want to write a real-time strategy game with 200 or thousands of units because, you know, your PC will probably burn. But if you have a fire extinguisher on hand, go ahead, that's going to be fun. So I am planning to implement source-style networking. Think about Counter-Strike and such. Valve actually has really good papers on how it works, so that's what's planned. And mind you, this will live alongside rollback, which will be amazing to figure out in terms of architecture, but it will be a fun challenge. And there's also eventually, no idea when, other approaches like lockstep for real-time strategy. Again, this is far into the future, but worth mentioning, I guess. And okay, but I don't care about all of this. I don't need this mess of a rollback. I don't care about cheating at all. I just want to make games. Godot is probably gonna be fine. Anyone feeling like this? Okay, some maybes. You are just too kind. Okay, so even with all this, why would you use Netfox? So first off, I'm gonna show you a quick demo. This is, once again, client authoritative, like the first one, but this time with Netfox. Okay, we can move around on the server, on the client. I think this should be pretty familiar by now. I can cheat any way I want. And even if the latency is just horrible, it still works great. So why did I bother showing you this? Because in this demo, you do not need to muck with rollback and think about resimulation and time travel and all that mess. That's just not there. You just send the data and it's there and it's done and it's simple. And it works with Netfox. But if you noticed, whenever I started the demo, there were two windows. They tiled neatly to either side of the screen. The game connected automatically. Yeah, that's Netfox. You just click a toggle in the project settings and it does for you. You also notice that I had these buttons to adjust the network conditions. That's Netfox. And mind you, this is not even something I built kind of on top of it for the demo. This is just built into the thing. There's also schemas. Actually, let me show you a snippet of code real quick. Where did I have that? Maybe here. But while I'm looking for it, oh yeah, this one. Hope it's visible. But the idea is that for each property that you want to synchronize, you can explain to Netfox how it should be serialized. So let's say you have a position. You can ask Netfox to send it as 3 16-bit floating point variables, which is, you lose a bit of precision, but it's a tiny map. The coordinates are small, it's all fine, and now you have your position synchronized from 6 whole bytes, similar to this quaternion, also 16-bit. That should be 8 bytes. And cool thing is that this works with any version from Godot 4.1 upwards. And the earlier versions did not support this kind of 16-bit serialization, so it just falls back to 32 bits. But again, it works. Anyway, schemas. As I mentioned, it does div states, which is also useful for client authority. Again, it just sends what has changed, nothing else. There's also a fixed tick rate. As I mentioned, the game updates at, let's say, 30 ticks per second. It's configurable, not to worry, you are not hard-coded to 30. It does interpolation, as mentioned, also useful. Synchronized clocks, also some convenient signals, like signal when the server is started. It's around the connection events. And if that's not enough, we've got a documentation website you can browse now as of recent with a whole class reference. There's multiple examples, actually, including a small game that you can play with your friends. There's also a pretty neat logging utility. So, I mean, have you guys put a bunch of prints inside your game to figure out what the heck is wrong? As it should be. All right, and Netfox has something for that as well. So it has a logging utility that you can use, and each of the log messages includes which peer is logging, where are we in the game, as in game time, the logger name, etc. So I found it personally to be pretty useful. You also get some performance monitors, custom ones in how much stuff is being simulated, how many ticks, etc. All right, let's move a bit beyond netcode. Because cool, I have made a game, amazing, time to test it with a friend. But hold up, how do I connect to this guy? Okay, we can do a dedicated server. That's a recurring cost. Not necessarily an option to everyone. Also, you can just ask your friend to host, except it usually does not work because routers decline direct connections. Okay, you've got port forwarding. You can ask your friend to configure the router to let data through. Routers are happy. Your friend is not. Your players are very much not. Unless, I guess, your target audience is network engineers, in which case this is fine. Okay, you can do NAT punch through. Because if you think about it, let's say you open a web page, you send some data to the web server, and some data comes back. Why does the data come through? That is because when the data comes back, the router sees that you've actually sent some data their way, so surely this must be a response. And you can use this by throwing data at each other, and eventually traffic will go through. Routers are happy, players kinda. And the thing is, there are some networking configurations where even this does not work, in which case you can use relays. They are kind of middlemen for data, so you send the data to this public address, and then that public address forwards it to your friends. Amazing, excellent, except now you need a public server to act as a middleman. But routers are pleased, and that's what really matters in all of this. Okay, so what are your options? Steam, everyone loves Steam. Steam is great. It also offers some relays alongside with your game. And if all you want to deploy to is Steam, great, problem solved. If you want to deploy to Steam and some other places, problem partially solved because you probably want other stores to work as well. So there's this thing called Nore. For disclosure, it's a thing I built, same as Netfox, open source, MIT license, and it can do an NAT punch through for you, and it also does relaying, so it's kind of foolproof. It is self-hosted. You can just put it anywhere, have it run, enjoy the game. And if you don't want to muck about with your own server, there's also a free public instance just for testing. Really, you can just use it, do whatever. Oh, cool, another misconception. I have tested this with another player and it is fine. No, it is not. Oh, anyone who fell victim to this? Cool. All right, once again, I'm really happy that I'm not the only one fooled by these. Okay, so no, it's not fine actually. If you can test it with one player, that's your basically sanity check. You do not have any syntax errors, missing references, and I have 10 minutes, so I need to hurry up a bit. If it works with two players, cool, it's kind of replicated, because the server knows about everything that happens. That's the server's job. You as the player know that you are doing the thing because you are doing the thing, but the third player has no idea about any of this unless the mechanic works in multiplayer. So that's why I really, really recommend of testing with 3 players. Okay, conveniently, that's my link slide, which means that I have covered most of what I want to talk about. And not to worry about these weird links, I have the biggest QR code this facility can offer. I'm honored to be bringing you all this QR code. You can scan it, and I think I have some bonus slides as well. No worries, I will bring this QR code back. Who's using this thing anyway? I have been talking a bunch about Netfox, but is there any games out there? Yes, there are. Bubble Battle, it's on Steam. It's the first commercial release using Netfox that I know of. It's a pretty fun little party game. Basically, you want the other guys to fall down while you yourself are staying up. And this is actually made by Matthew Ponder. Rings a bell to anyone? Yeah, not to worry. He was at last year's Boston event. So I would go check his name, search for him on YouTube. He has a pretty good talk. There's also Nitro Turtles, Super Mario Kart, but with turtles. And I think it looks amazing, to be frank, and actually plays well. Chrome Carnage. This is in progress. Basically, personally, I would describe it as GTA 2, but with more multiplayer and more blood and more chaos. So I think that could be something of fancy. Plan B4, still in progress. The game describes itself as Hotline Miami, but with your friends. Okay, that's it. That's all. We have managed to make it on time. All right, thank you. Any questions or just things you want to yell at me? Yes.
In your testing, I just wondered, have you found that things like universal plug and play work at all? Do people actually have routers that still work with that?
Oh, you mean UPnP?
Yes.
Yeah, I steered very clear of that. As far as I know, they don't really like it. It's kind of considered a security risk. And fun fact, even on my own router, I cannot enable it. It's just disabled by the ISP. So I did not mess with that at all.
When using Netfox, how difficult would you say it is to make a multiplayer game compared to, well, not doing multiplayer, single player?
I'll need to consider my response to this one. I think that it really depends on the game. There's a bunch of mechanics that Netfox works really well for, like running around, general motion being predicted, etc. That's great. And I don't think it gets much easier than what Godot offers, because you just write your code and it synchronizes. Netfox tries to do the same, but with server authority, so it's more difficult to cheat. So, yeah, is that an answer?
Yeah.
Cool, thank you.
Okay, so two short questions. I don't know if the answers are going to be short. So, for example, let's say part of my state is maybe 4 booleans and a number up to 10. So maybe that fits inside a single byte. But I don't know if Netfox is smart enough to figure it out, if you can describe it somewhere. And the other question is, when you're doing rollback, how do you handle, for example, if setting a property has some side effect because it has a setter or whatever, or if you have despawn or spawn something and you have to undo that, is that something that the developer has to custom script, or I don't know?
No and yes. To actually explain. So first off, combining multiple properties into a single field, that does not exist at the moment. I did consider it for a while, but the whole thing behind the what has changed check in Netfox is based on properties and multiple things. So you can do it, but you would have to do the bit field thing on your own. So you have a single property and then you do the job there. And hold on, what was the? Oh yeah, the side effects. Yeah, that's what makes rollback difficult, in my opinion. There's tools for it. There's this thing called rewindable actions. Let's say, for example, for firing a gun. These are for events that you predict that they happen, and it gives you really convenient tools to manage if they actually did not happen, and you need to undo that, or if you thought they won't happen but they now did, etc. Oh yeah, and there's also this thing called liveness tracking, because you can't just simply despawn a thing, because the game might want to resimulate a point in time where that thing still existed. So that's not in the latest release, but in the latest version on GitHub, there's support for that. So there's tools for these.
Okay, thank you very much.
Thank you. I think there's someone on the front as well.
Fantastic talk. Thank you for making this tool. I think it's super cool to have something, to automate all of the super complicated nitty-gritty of multiplayer game dev. 2 questions. 1, is there a way to deal with like conflict resolution, i.e. 2 players try to pick up an item or something at the same time? The server needs to kind of determine like how to handle that, and then rollback needs to be applied in a pretty complicated way. Is there any way to do that in Netfox? And second question is just, you talked at the beginning about having like local co-op alongside online. Is that also something that's doable within Netfox?
Conflict resolution. I'm not sure how hand-wavy this is of me, but my idea is that in theory this should not happen at all, since you have the server, so the server will just sort it out kind of by default. So if you have 2 players wanting to do the same thing, the server will process the inputs in order. The first one does the thing, the second is denied. All good. The second was, can you help me out, please? Oh, yeah, couch co-op and online. This is kind of orthogonal to Netfox itself, but by the way, how I approached it was that each client can register their own inputs or player slots, and then they send a request to the server responds them, and it's all fine. Oh, and as for your first comment, for making this add-on, thank you for the kind words. Come hang out in the Discord. Everyone's welcome on the Discord. Right, do we still have time? We've got time and questions, it seems.
Okay, I don't know if it's a stupid question or not, but so when using Netfox, you don't need Godot's high-level API anymore. You kind of just like, because Netfox is taking most of the work. What about RPC calls? Is that something that Netfox also handles?
Actually, that's an excellent question. If I could have like written one question in advance and ask someone to pose that question, that would be this. So thank you very much. And maybe this is something that I should highlight more with Netfox, is that Netfox does not want to replace Godot's tooling, but build on top of it. So you can still use RPCs, or another question, does Netfox support WebSockets or such? Yes, it does. It uses Godot's transport system. So anything you can do with Godot in this sense, you can put Netfox on top of it. For RPCs specifically, if you want to modify stuff that is managed by the rollback loop or a rollback synchronizer, rollback does not take kindly to data being modified from the outside, but if you avoid that, RPCs work just fine. So you can use them as you would like, alongside of any Godot built-in stuff.
Last question. Hi, I'm really glad to hear you building a solution to deal with cheating in games. Do you have any solution against aimbots?
Yes and no, in the sense that I do not have anything running client-side that detects aimbots and such, so in that sense, no. But in the sense, yes, that we have visibility management that you can use to, let's say, there's a competitive game and this other player is hiding behind a wall. Your server can do line of sight checks, and if I personally cannot see this other player, then I can ask Netfox to not send data about this other player. So in this way, you kind of circumvent the aimbots because you literally do not have the data of the player.
Thanks. Thanks for a great talk and a great tech. Really would love to try it. A question I have is, you had said about client-side prediction, which seems super reasonable. One thing I'm less sold of, rollback and rewind. And you also said that that has a performance cost, especially as the number of people playing grows. So did you consider using the other portions without this one? How much does it degrade people's experience, and also if you can try it in Netfox as well. Thanks.
Sorry, could you revert the last part? I'm not sure I follow.
Yeah, I'm wondering if you can do all the things except rollbacking to place the input and rewind. Like I imagine if you like lagging around like some input moment, like specifically taking some items, that's acceptable. But as long as you move around without lag, that's reasonable. No?
Yeah, I think I got you. That does not currently exist with Netfox, and at the time I started building it, it did not cross my mind even. But I think pretty similar to what you describe is what source-based games do, like Counter-Strike and such. That has no rollback, but it can still compensate for latency, let's say, when you fire your gun. So that's something I plan to do. Cool, thank you. And I think it is time for me to do some closing words. First off, check the QR code. It takes you to GitHub with all these slides and the demo projects available. Feel free to play with them. Also, if you are interested or would like to talk, come hang out on the Discord. But also come up to me, yell at my face, anything you would want. I have some these nifty little name cards. Take as much of them as you would like. I have 50. I do not need 50. Yeah, that's... I will be also here tomorrow, probably with a blue shirt with a Netfox logo. So, find me anytime you would like. Thank you again. This was fun.